Bom dia. Bom dia. Bom dia a todos. Vamos intensificar com esta terceira aula do PSR. Hoje nós temos vários assuntos para fazer, como vocês veem ali no guião, que já estava online desde a semana passada, mas antes disso eu vou falar do trabalho prático, que é para fazer até para a semana. Não é muito difícil, por isso é que é até para a semana, mas ao fim e ao cabo é para construir em cima daquilo que nós já fizemos e fomos fazendo ao longo destas aulas e ainda vamos fazendo a dois, ok? Portanto, a ideia é fazer um trabalho por grupos. Os grupos são sorteados, como eu vos disse na primeira aula, e são sorteados para todos os trabalhos práticos. E então, nós temos que fazer um programa, escrever um programa para fazer um teste de typing. Não sei se vocês sabem o que é um teste de typing, é uma coisa deste género. Nós não vamos fazer uma coisa tão complicada. Agree, start test. Portanto, basicamente ele vai-me dizer para escrever palavras. Star, Wars e por aí fora, ok? Portanto, basicamente ele diz-me o que é que eu hei de escrever e eu escrevo e o programa percebe se eu me estou a enganar. Por exemplo, se eu escrever aqui famous mal, ele já me diz que eu não estou a escrever direito, ok? E por aí fora. Portanto, é um programa que supostamente, uma aplicação que supostamente consegue perceber se o utilizador é um bom typer ou não, se consegue escrever aquilo que é suposto. Obviamente que nós vamos fazer uma coisa muito mais simples do que aquela que eu vos mostrei. O que pretendemos é uma coisa deste género. Portanto, queremos um script em Python, um programa em Python, que comece por ser lançado com várias opções. As opções nós já aprendemos na aula passada como é que fazemos, usando a biblioteca argparse. E o que é que as opções fazem? Depois vocês podem ver com mais detalhe lá no guião, não é nada outro mundo. Por exemplo, o max value define-se qual é o número máximo de inputs que vamos pedir ao... O número máximo de inputs, não. Qual é o número de inputs que vamos pedir ao utilizador. E se usarmos aqui no PM o time mode, na verdade, este número 10 não é considerado. O número de inputs é considerado o número de segundos que vamos estar a perguntar coisas ao utilizador. Ok? Portanto, seria qualquer coisa do género. Olha, eu quero ficar a perguntar coisas ao utilizador durante 10 segundos. O utilizador carrega, ele diz, escreve a letra tal, sempre que eu me engano ele põe a vermelho, sempre que eu acerto ele põe a verde, qualquer coisa do género. E depois no final, pretende-se que, lá está, estamos a aprender Python e a utilização de dicionários, pretende-se que ele imprima, isto aqui começa por uma chaveta e acaba numa chaveta, portanto é um dicionário com várias estatísticas do ensaio que foi feito, nomeadamente a precisão, o número de acertos, o número de inputs e por aí fora mais outras estatísticas que estão todas discriminadas lá no guião. Okay? Eu não sei o que é que vem a seguir. Portanto, reparem aqui que eu estou a usar o time mode, ou seja, eu estou a levar isto no máximo até 10 segundos. E aqui é uma das coisas que dá mais trabalho, é assim, um daqueles detalhes mais diabólicos, que é, deixa-me ver sempre para trás, que é aqui, se isto for em tempo, se for em número de tentativas é fácil, são 10, uma pessoa escreve 10, demora uma hora para cada uma delas, são 10 horas, não há problema. Mas se forem 10 segundos no máximo, então o programa vai pedindo input ao utilizador e à velocidade que o utilizador escrever os inputs, assim será o número de inputs quando chegarmos aos 10 segundos. Mas, por exemplo, imaginem que o programa pede um input ao utilizador aos 9 segundos e meio. E depois o utilizador fica meia hora a pensar. O programa deve esperar até que o utilizador escreva o último input E esse último input já é feito para além dos 10 segundos, aí é que o programa termina. Okay? Portanto, os 10 segundos são o tempo máximo até que se pode pedir um input, mas depois temos que esperar pela resposta. Por isso é que este programa não demorou 10 segundos, demorou 10,39. Okay? Portanto, vocês também têm que arranjar uma forma de fazer isto. Aqui podemos também, eu acho que vou mostrar a utilização, toca o número e não sem o UTM, o Use Time Mode. Portanto, aqui, 50 é capaz de ser mais, 50 inputs. É o atalho, em vez do max value 50, em vez de escrever menos max value, escrevo menos NV, é só o atalho. E pronto, e o teste está a ir até 45 inputs. E depois andamos para aí até, quando chegamos ao 45º input, ele para. Nada de especial. Vocês têm o guião já publicado no GitHub, portanto a parte 04 é o guião do trabalho prático. E tem aqui, já agora, veja se o meu microfone está a funcionar. Alguém liguei o som? Isto está a capturar o... Está? Ok, obrigado. Então, vocês têm aqui tudo o que é preciso, está aqui tudo explicado. Se tiverem alguma dúvida, podem me perguntar, obviamente. Okay? Acho que não há grande dificuldade neste trabalho prático. É mesmo suposto ser simples, só para puxar um bocado por vós e vocês, digamos, entrarem um bocado com mais velocidade dentro do Python. Em termos dos grupos para os trabalhos práticos, eu vou publicá-los já a seguir, talvez na aula prática seguinte ou coisa do género, mas se não for hoje de manhã ou hoje à tarde. Os grupos são estes. O que eu fiz foi sortear, ok? A única coisa que eu não sorteei foi aqui o Miguel qualquer coisa, Miguel Tavares, que me pediu para estar sozinho porque é trabalhador estudante e não pode estar aqui. De resto, os grupos têm entre 3 e 2 pessoas e foram todos sorteados, ok? O trabalho faz-se bem até com uma pessoa só, portanto não é por aí. Não ficam muito prejudicados se ficarem num grupo de 2. O que eu vos pedi era autorização para publicar então estes e-mails, portanto eu vou publicar no e-learning, vou pôr este PDF, onde vocês vão conseguir ver o grupo e tem o e-mail do vosso colega. Portanto, depois vocês entram em contato pelo e-mail, falam todos uns com os outros e agora eu o argumento de não tive tempo para me encontrar com o colega, porque nós temos horários diferentes, somos de cursos diferentes, já foi usado o ano passado, mas eu não concordo muito com ele, porque hoje em dia tudo se faz por Zoom, ok? Portanto, vocês não precisam de, basta encontrarem-se sábado de manhã ou sexta à noite, sei lá, é só no Zoom e não tem nada que saber, podem trabalhar em conjunto no Zoom. Pronto, se não tiver o nome, enviem. Eu acho que há várias pessoas que entraram mais tarde, eu sei que o André está ali também, vocês também entraram mais tarde, também não devem cá estar. Por isso, se não estiverem, enviem-me e eu coloco lá, ok? É porque eu tenho sempre o problema de, sempre que eu vou buscar esta lista lá à base de dados, no dia, passado 5 minutos eu quero uma pessoa nova. Eu já desisti de buscar a lista atualizada. Vocês digam-me que eu acrescento, ok? Pronto, as regras, para a malta que chegou mais tarde nesta cadeira. As regras de avaliação são um bocadinho diferentes do habitual. É possível que um ou mais elementos do grupo peçam para ter um desconto. Eu não vou estar aqui a gastar muito tempo para explicar isto. Vocês podem ver nos slides da apresentação como é que isto funciona. Os slides da apresentação esses que estão, salvo erro, no e-learning. Okay? Se não estiverem, mandem-me o meu que eu ponho lá, mas estão no e-learning. Mas o normal seria que todos trabalhassem o mesmo e, portanto, não haja desconto declarado. Mas se, por exemplo, aqui o Gonçalo tiver 0, por exemplo, 13 valores, e a pessoa do grupo dele também tiver, obviamente, a mesma nota, 0, 1, ok? Então os dois com 13. A Isabel, por exemplo, podia dizer assim, mas eu trabalhei menos que o Gonçalo. Então, e quero ter menos 2 valores. Mas atenção, a Isabel diz-me isto antes de saber que a nota dela vai ser 13, ou que a nota do trabalho vai ser 13. Portanto, diz isto, e eu ponho aqui 2 valores de desconto. Então o que aconteceria é que estes 2 valores são retirados à Isabel e são revertidos para o Gonçalo, que ficaria com 13,33. Ok? Hello, good morning. Se não se importarem, eu mudo para inglês por causa da Mosgan, is it? Não. Yeah, ok. Eu na altura perguntei, mas volto a perguntar. Alguém tem stress que eu falo inglês? Não? Não? Okay, so we continue in English because Mojgan is late. She had to take her child right to school. Okay, so in English we continue. Let me take this away. Otherwise, Gonçalo and Isabel don't need to do anything to pass. Okay.
Sorry for delay because I take my daughter's.
Yes, you told me, no problem, no problem. And that's it, okay, nothing more. You just have to, when I publish this table, to contact your colleagues and start working. You should, how will you present? Next week during the practical class. Notice these groups are all given between people of the same practical class. You will present, all three or all two of you will present the assignment working. And the grade will be done based on this criteria. So this is also important. These are the criteria that I'm going to use to evaluate your work. So I will also publish this. So this is transparent. You can use it to decide what you should develop more in your program. Okay? Any questions? No questions? Okay. So I will try to publish this fast, and I will send you an email when I do. Okay, so now we go into the part 03, which is this week's part, which is here, okay? So for this part, we are talking about the introduction to Git and GitHub. We've done some introduction during the practical classes last week. So I will leave this part more to the practical assignment. If you need, you ask me and I will tell you how you can use Git and GitHub. And then we are going to focus typically on the problem of how to build our programs and what's the best idea, the best way to do so. And the answer is already, I can give you the answer. There is no best way. There are better ways than others, but there is no perfect way to do the program. And in particular, this last exercise, well, not the last, this last group of exercises, the complex numbers, is meant to give you this idea, or to give you this message that there is no single way of doing a program. That's why when students say, oh, I did the program exactly the same as my colleague, but I never looked at my colleague's program, it's a very difficult to believe statement, because programming is like writing. It's almost impossible that you do exactly the same as the other one. In this group of exercises, number 2, number 3, and number 4, what we are going to do is try to do the same problem, or to solve the same problem, the problem of creating an algebra for complex numbers. That's just an application without much use, but it's just something to work on. So we are going to try to solve this problem by implementing a program that first works with tuples, then with named tuples, later on with classes, okay? And if I have some time, I can also do it with dictionaries. But that's to give you an idea of how many different ways you can use in order to solve the same problem. So I will not, I hope you try to do it at home, and we can also address it in the practical classes. Now, so I'm going to jump right into the complex numbers, okay? So if you know what complex numbers are, you are very lucky. I don't, so I don't remember, or I didn't remember when I saw this exercise, so I had to review. So complex numbers have a real and an imaginary part. For example, 7 plus 3i, and the idea is to implement the algebra. So we would have to know how we can sum the complex numbers and how we can multiply them. So here is the formula that we must implement, okay? If you have a plus bi, that's the first complex number, and c plus di, that's the second complex number, what you must do is you must add the real part, a plus c, and then you must add the complex part, b plus t. And that's the sum of complex numbers. That's how you implement it. For the multiplication part, it's a bit different. And the formula is this one, okay? So I will not go into detail because we will implement in the future next. But so let's try to build a program that will take complex numbers and then be able to multiply them. How can we do this? So let me go into, I will collapse everything. PSR part 03. So this should be the T. And here I'm going to do exercise 2. New folder, EX2. So I'm also going to copy just for making it fast. Exercise 4A, let's see, main. I'm going to copy this there. So if I press Control, a plus will appear. That means I'm copying, not moving from one place to the other. So this is the exercise, the file that I want to change. It has a lot of stuff that we don't need, so I'm going to start taking it away, okay? These are all the functions that we had before. So all I need is a main, the shebang line in the beginning, the main, and then nothing more for now, okay? So print starting with complex numbers. So the big difference, so the freedom that you have to build programs is mostly because you have absolute freedom to represent information in any ways you want. And that's how we are going to vary, to make so many variants of this problem of solving the algebra of complex numbers. So what I'm saying is that we have variants because we have different ways of representing the complex numbers. So the first way we are going to try to represent the complex numbers, well, is going to be this one. We are going to represent complex numbers as tuples. So what are tuples in Python? Actually, I can copy this part, copy, paste. So what are tuples in Python? Tuples are, I will put this, otherwise he's always going to complain. Pass is a Python expression to say do nothing, but there is an instruction here, otherwise it would complain that there is a function defined with no instructions inside. At least there is one instruction that does nothing, but it's one. So I'm going to define the complex numbers as tuples. Tuples begin with a parenthesis, and then you can put as many elements as you want. Tuples are groups of things which are different from lists because they are immutable. So they cannot change. Once you define them, you cannot change them. You cannot add a new element to the tuple or remove one. Also, tuples are lists of things, not of two things, but of n things. So I could have a tuple with 4 values. I could also have a tuple different from this. But let's say that the tuples will be this, and a complex number in this case is represented as a tuple, real, imaginary, right? So the first part of the tuple is the real, the second one is the imaginary component. And so here we define two complex numbers, C1 and C2, just for an example to be used later. And then on line 24, we are going to compute complex number C3, which is the result of adding C1 plus C2. Okay? Therefore, this add complex is a function that we must implement. Okay? So how do we implement? Please interrupt me if I'm going too fast or anything. You know how I start moving fast whenever I don't have any feedback. So here, the add complex function will receive an x and a y. These x and y are actually the complex numbers. So x will be a tuple and y will also be a tuple. So if I want to implement this addition that we've seen before, I will even copy paste it, copy, paste. Okay, so here's the formula. By the way, I can also copy paste the multiplication formula, and then we don't have to come back here. Okay, so look at the formula. There is an a plus bi, blah, 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 blah. So I can say something like this. If x is my tuple, I can say, oh, a is the real component of x and b is the imaginary component of x. So a comma b equals x. So this will unwrap the tuple, which contains two values, two components, into two separate variables, A and B. And why am I saying A and B? Because that way I don't have to write the formula, I use it immediately from here. Then I can say C, comma D equals Y. This is just unwrapping the tuples, right? And finally, I will compute the real component, which will be, let's say, A plus C, as it says there. And I compute the imaginary component, which will be B plus T. I'm doing something wrong here with the okay, oh yes. Okay, so I've computed two variables, real and imaginary, which are just the sum of the complex numbers. And now, finally, let's say that this function will receive complex numbers as tuples. So it makes sense that the output of the function will also be a tuple in order to maintain the same representation. So I'm going to return a new complex number, which will be a tuple. Therefore, I put the parentheses with real in the first value and imaginary in the second. And here is our add complex function. Okay.
Let's say we would want only to add the natural part. Would we
the real parts?
The real part.
Okay.
Would we have to
Yes.
Or can we just reference it?
Yes, you can. You can. So you don't have to unwrap the tuples. You can actually do it like this. So how do you access the first value of a tuple? You access it like this, x 0, and the first value of the second tuple, y 0. So these are the two imaginary real components, sorry. And here you can put x1 for the second one and y1 for the imaginary component of the second tuple. So so this is alternative 1, and this would be alternative 2. Okay. So I did this unpacking because it was easier to understand what I was doing with the formula there. But it's the same. So we can at least try to see if this works. So I'm just going to, this print complex is a function that I also must implement. So for example, I will do a function that will, again, have the real and the imaginary part of a complex number, x, and then we'll print the str, which is the conversion to text of the real, plus is to put together pieces of text. Then I want to put the text plus, and then I will put the imaginary part, and then I will add an I. What am I trying to write here with this print? I'm trying to write this, A plus BI, or 7 plus 5i, something like this, okay? It's just to print a complex number. So now I already have the print complex function, so I'm just going to print complex C1, then print complex C2, then print result is like this. Okay, so let's try to make this work. I'm going to pick up a terminal, copy paste the folder path. That way I can cd to my folder path, right? And now I have here my main, so I do clear just to make sure the screen is clear, and /main. So here it is, 5 plus 3i is the first number, minus 2 plus 7i is the second one, the result is 3 plus 10i. If you do the math, it works, okay? Nothing special here. So now we can go and try to do the multiplication part, which is more or less the same. So I'm just going to do the unpacking. So here I've unpacked, and now I have to compute the real component, which will be, let me take a look at the AC. I think the real part is only AC. Yeah, that's the real part. Okay, so the real is going to be A times plus C. The imaginary will be A times D. Oh, this is times, it's not plus, so this is times. And the imaginary will be A times D plus B times C plus B times. No, wait, this is also real, right? Because I to the power of 2 will be real also, right? Yeah, like this, okay. So AC minus BD, AD plus BC. So AC minus BD is the real part. AC minus BD, the real part. And AD plus BC, the I part. AD plus BC. AD plus BC. Okay, the imaginary part. And finally, we return also in the same format this. So we have our multiply complex function. Here it is. Nothing special about this one as well. Let's test the multiplication. Result of addition is result of multiplication is, right? Okay, so the result of addition is 3 plus 10i. The result of multiplication is minus 31 plus 29i. I'm not sure if this is correct. It should be. Okay. Any questions? No questions? Okay, so we move on to the next exercise. And the next exercise starts from the following assumption, which I think it's true. So when we are doing programming, we get used to, at least people who program for a long time, new people don't have this defect, but old people do. We are used to try to do things for the machine. In terms of programming, what does it mean? It means that the program starts to get complicated and complex, and we are okay with it. We don't worry that it's becoming more and more complex, because for us that is natural. And this is not the best way to go when you are trying to program. You should try to make your program as simple as possible in order to always be able to improve it and update it and so on and so forth. So try to resist a bit this idea of, oh, it's getting complicated, but that's normal, because it doesn't have to be. And one of the things that makes programs hard to understand is when I have to memorize stuff. So my memory, I have a chicken memory. I don't memorize anything. So whenever I have to memorize something, in particular with programming, for me that's hard. In this case, I have to memorize something which is not there explicit in the program, which is the following. The real part of the representation of the tuple, the real part of the representation of the complex number is the first element of the tuple, whereas the second component of the tuple is the imaginary part. And this assumption here, that I'm putting real imaginary, is carried out into these functions. For example, when I do AB equals X, I'm assuming that the real is the first. Otherwise, I would have to put BA equals X. And also here, if I do this, when I put there X0, that means I'm assuming the first part is the real one. So there is an assumption here, which is not explicit. It's just implicit. I have to memorize it. And this is not good for programming. So if I have to memorize, that's a downside immediately. Programs should not have to put the weight of having to memorize something on the programmer. Of course, this is an ideal situation, but in this case, we can do more than we have here. In particular, we can use named tuples. So instead of me having to memorize which one is the real and the imaginary component, I can actually use named tuples to help me with that. How can I do that? First, I'm going to create a new exercise. So this exercise 2 will be copied. And now I have, where is my exercise? Copy, paste. Yeah. Rename. Now I have exercise 3. I'm going to edit the code from exercise 3. so that I can change. So the goal now is to use named tuples. Also here I have to go to exercise 3. Okay, so the goal now is to use named tuples. How do I use named tuples? I use them like this. So I'm doing a from collections import. That's just the way to get the named tuple library. The library is the collections, the named tuple is a feature of that library. So I'm just going to define complex as a new type, a new tuple name, which is a named tuple called complex, here it is, and then contains the following fields, R and I. If you want, we could say real and imaginary, but let's just say R and I, okay? So this complex now will help us to define the complex numbers. So now I'm not going to define complex numbers as this. So now a complex number is represented by a named tuple complex. Okay, so this goes away. And how do I represent this? So I say C1 equals complex of 5, 7, something like this. And C2 equals complex of, I don't know what the numbers were, 2, 4. Okay, minus 2 and something, doesn't matter. So if I do this, exit 0, so I'm just going to bring my program up to this place. You can see that I'm already defining the C1 and C2 using the complex named tuple. And then I'm going to do the print complex, which already assumed what we had before. So perhaps this function will fail already because it's using an assumption that is no longer true. Okay, however it works. Why does it work? Because named tuples can also be used, if you want, as regular tuples. So you could use named tuples exactly like you use the regular tuples. Of course, this is more or less stupid because if you are going to use a named tuple like a regular tuple, you shouldn't have go into the trouble of defining a named tuple. In any case, it works because of this particularity of named tuples. However, we can define the real and the imaginary component in a much better way. We can pick up the complex number and say that we want the, well, I can even, yeah, the R component. So if I do this, imaginary, and I put here the I component, it also, oops, doesn't, double indices must be slain. I already had this problem last year, I think. I don't remember. Must be slices, not string. I don't remember how I did this. Well, this, it works, of course. Let me see my notes. How did I do this last year? Because I remember I had this problem of how to call the named tuples. It should work. I'm not sure. Well, let's try. So, parte 3, exercício 3, talvez. Main. Complex RI. It's dot R. Okay, it's not like a dictionary. I always forget about this. I don't use named tuples a lot. So it's not X and then R. It's at X dot R and X dot I. Okay, so it's like a field of X, the real component. If you were to change this part to real and imaginary, you would have to do X dot real and I dot imaginary. Okay. Not yet. Now it was my fault. Okay, now yes. So it works. And why is this much better to do instead of the previous one? Because now I don't have to memorize that the real is the first and the imaginary is the second. I can just say X dot real and X dot imaginary. No matter if it's the first or the second, it always works. What else now? Oh, now I can expand this to the rest. So I'm not putting here real and imaginary. I'm just using RI because it's easier. RI. Okay. So now we can just change the adding of complex numbers to this new functionality. So I'm going to change this function here in order to make it work with the new representation for complex numbers. So who can help me? What do I need to change in this function in order to make it work? Please, go ahead, please. Okay, so yes, I agree with generally with what you said, but I didn't understand explicitly what I'm going to write. So what do I start typing? Mm-hmm. Okay, great. Nice. That's it. So C and D. Oops, sorry. Y. That's it. You all agree? You have to speak louder.
Isn't it A and B with it?
Why don't it was A and B before here? Why?
No, it's in C. Yeah, right. It's correct.
It's correct for you?
Yeah.
Okay. So no questions. You think that he, your colleague's suggestion is working? Okay, let's see if it works. It's not working, but it should work. Where did we get it from? Add complex. Result of addition is tuple object has no attribute R. Really? Ah, okay. What's? Oh, okay. No,
Because you can say it's a complex type of tuple.
I don't have to. I think when I say here C1 into the add complex, it should be of type complex already. So let me comment this just to make sure that we are only, perhaps the problem was in the multiplication. Let's try the addition only. No, it was in the addition. Line, okay. Now okay, so I will tell you where the problem is, where it is, and then you will tell me what the problem is, okay? So the problem is here, in the print complex function. You don't define what? In the addition. Okay, so first let me tell you, so we are having the problem in this print complex. However, we are not having problems in this print complex of C1 and C2. So our problem is only in the print complex of C3. Your colleague suggested that perhaps the problem is in the add complex function. I'm really not sure. You have to tell me. So Diga, Bruno. Okay, that's the problem. That we are adding complex numbers, and then we are not returning our new data structure. We are returning the old one. So here we have to return also a named tuple complex. That way, the return will go and be copied to C3, and then when we try to print C3, we are going to try to access the .r component which will exist. Make sense? So now it works. Okay. We can do the same for the part about multiplication, as simple as this. So we are going to get A, B, C, and D in a new way. And then we are going to return the complex tuple like this. And it all, oh, sorry. For the multiplication, I would have to print this so that you can see it's working. Okay. So the multiplication also works. And that's it for named tuples. I don't use them a lot. I use dictionaries, and whenever I can, I use dictionaries. And so I can show you how we can do this with dictionaries. Let's call it exercise 3 dictionaries. Main dict. There is an underscore here or not? There must be an underscore. Okay, now yes. So for the main dict, I'm going to do a new representation, not based on complex, on named tuples, but on dictionaries. And that means that whenever I want to define the complex number 5, 7, I must do the following. So now, a complex number is a dictionary, a Python dictionary, with 2 keys, a R key and a I key. Okay, so a dictionary is a data structure in Python. I think I told you already about this, but I will give you a slight remember. So D equals like this. If I do the brackets, not the square brackets, but these brackets, chavetas, it means this is going to be a dictionary. And the dictionary is a set of pairs of keys and values. So I can say something like this. Real, or R, will have the value 4. And I, or imaginary, will have the value 6. So I can define my complex number like this, like a dictionary with 2 values, with 2 keys and 2 corresponding values. That's what I'm going to do. So here I'm going to say C1 is going to be a dictionary with the real key, the R key being 5 and the I key being 7, close dictionary. The other one is can be 2, 1. Okay, so I have a new way of defining the complex numbers. Again, we can define them in many different ways. And now that they are dictionaries, I have to adapt the rest of the code. So first, the print complex, how can I do it? If this is a dictionary, now in order to access the R key of dictionary X, because I'm going to put C1 here in print complex, I have to do this. R, okay, sorry. So that's how I access the key R in dictionary X. And this is how I access the key I in dictionary X. And also this should work. So if I do main dict, it also works. So I'm already printing C1 and C2. So now you tell me what I must change in order to have this working for the addition. So C3 will be add complex of C1, C2. Now we know that C1 and C2 are represented as dictionaries. So what must I do in order to change this function add complex? Vocês têm, eu ouço mesmo mal, eu não sei quem é que falou, mas falar não dá, eu não consigo. Tem que, para si pensa assim, yeah, go ahead.
I need the return function. To change the format.
Okay, so you want to return a dictionary, that's it. What do I write here? Tell me, Henrique. You can try to help him, don't let him. Yeah, well, if it's a dictionary, start with a bracket. That's a good idea. Next.
The same keys that we did before on the dictionary.
Right.
R and then real.
R and then real, which is the value of real. I and then imaginary. Right, makes sense. That's it. Anything else we need? Okay. Sorry, Tiago.
Run it and let's see.
Ah, good answer. Okay, we ran it and we saw it, and there is a problem in line 10. So line 10 has a problem.
We also have integration.
Exactly. Exactly. This is not the way to access keys in a dictionary. This was the way to access elements of a named tuple. So now we have to do something like this. E agora aqui. Aqui, paste. Yes. Okay, so this is how we extract the R key of dictionary X, and so on and so forth. So now it should work. Okay, that's it. Now it works. With the practical assignment, I will try to do the classes. So I will spend more time with the classes. But look, we've done already 3 different ways of representing the dictionaries. Now I will do the student way, the worst way possible. But that's what you do when you are starting. And perhaps I should have started with that one, but I will try to do the worst way possible. Because also it's important to know what not to do. Sometimes more than what to do. So I will use these 10 minutes to try to do a bad one. A bad example, okay? So we start from here. And the first idea would be a complex number has 2 values. So I represent them with 2 variables. So this kind of reasoning is very typical of people which that do not have a lot of experience with programming. So I can say, okay, so C1, let me say, okay, so let's say A equals 5, then B equals 7, then C equals 2, then I equals 1. These are my, and now I have to pass these 2 numbers to the print complex. So the print complex will receive 2 values, V1 and V2. And so now I have to put here the A and B, and there the C and D. And now I print first the V1 and then the V2, value 2. Okay. Then for adding the complex number, I can, I will need to add 4 different things. So I can put V1, yeah. I will see there, should be D. That's it. If you want to follow the convention, no? Students never follow the convention. So this bad example was, you didn't use it. Well, I can even tell you what my colleague would do. A1, A2, A3, A4. I would go crazy when I looked at into his code. A1, A2, A3, A4. Okay. And now here in the add complex, we have value 1, value 2, value 3, value 4. And we have to have, I think, so this will be value 3 plus value 1. And this will be value 2 plus value 4. And the return will be, I have to return I have to return the real and the imaginary. And now here, when I receive the add complex must be with A1, A2, A3, A4, and I will receive here B1, B2, something like this, okay? And then when I print, the complex number C3 will be B1, B2. Are you getting confused already or not? I'm very confused with this. Bad example. So it also works. That's the point I want to make before we finish the class, is that you can also do a program that works, although it's not well organized. I worked with a professor in DETI, which told me something very interesting, which was a good programmer is a very good person giving names to things. So giving names to things is a very important thing for programming. So a good name will help you, will take you a long way. If you start using A1, A2, A3, V1, V2, V3, it's going to be, it's going to get complicated fast. So be careful about how you name things. be sure to try to group your variables either in dictionaries or in named tuples or using classes, as we will learn in the practical assignment. Because what's the problem here and why do I want to pass this message? I want to pass the message that for now, you can say, oh, the teacher is saying this, but I can clearly do this and I can continue to work on this, no problem. So I know what V1, V2, and V3 is. And if I want to change the name of V3, I can call it B3. And here I will put V3, so I can still follow. Yes, you can, because you have a lot of capacity to do so. But a good programmer is someone who spends his potential not in following things that don't need to be followed. So if you do a bad code, your resources, your intellectual resources will be spent on trying to keep up with the bad program. If you do a good program, then you don't have to spend important resources understanding it. You can spend doing new functionalities or more important stuff. And that's the idea. If you are doing a very simple thing, you can still, for example, for the first assignment, you will still be able to do something not very well organized. When we start having more complicated stuff, for example, imagine a script like this. Yeah, like this. So if we now have something like this, which has all these input arguments, and then has all these calls to the functions, and then everything else, if this is not well organized, you will be completely, how to say, you will not be able to do a good program. So organization is paramount. That's the most important thing from a programmer's point of view, okay? So in the practical part, we are going to do yet another way of adding and multiplying complex numbers, in this case with classes. But that's it, I think. Do you have any questions? No? Okay, so let's meet in the practical assignments. See you.